Aloha, Rich Halverson here. This is ICS211. And in this video, I'm going to take you through lab 20.8, which is the sorted number list implementation with linked lists. So if we look at the problem here, on the right, we have the problem in Lamaku, which is complete the sorted number list implementation with linked lists program lab 20-8. And get it running using Visual Studio Code, and then add a menu just like we did in the last three labs. Okay, and this is very simple, and I'll show you how to do this in the end. It's just moving some code around, but it's something that you've done it so many times already. It should come easy for you, and that's something you can, I guess, leave this class knowing how to do pretty without thinking about it too much. All right, and then do all this and demonstrate. Okay, so if you look on the left, we have what the problem is. Okay, and this is an old style lab. I think this might be the only one that's an old style lab. But you don't have the window down at the bottom. You 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 actually, oh no, I guess, yeah, you modify this code, and there's three files. There's the lab program file, which is where the main is, but then there is a node.java file, which is right here. That's this. And we don't need to fill in any of this code. We don't need to do anything with this code. We don't need to do anything with this main code, except for uncomment it when it's time to test the second part. Uh, we don't need to do anything for this in the main program for this lab, but to add the menu, you will mess with this program, with this file. The file that this lab is concerned with is the sorted number list file. And what this is this is the class which uses the node.java class, and it's a linked list. It creates a linked list. It's a doubly linked list, which means it's got a tail pointer as in addition to a head pointer and tail pointer. And you're supposed to make you're supposed to write the method to insert a number into this sorted linked list, and you're supposed to write the method to remove a number from a sorted linked list. And the parameters for each of these is a particular value, a number, a value for that node. And so this is just a linked list of numbers, and each node is a number. And this thing you pass, you call this method if you want to add a number to the sorted list. It's going to add it in order. See, so the trick is you have to find the right spot for the list for the number, and then you instantiate a node, save the number into the value into the data field of the node, and then link that node in to this proper spot in this linked list that will exist already. And this is how you take it out. So inserting it means you let's draw a picture. Okay, so you have a linked list. Okay. And it's sorted. So I think it goes down. I think it goes up or down. I can't remember which way direction it goes. It goes up. So as you add these numbers, it starts out the list is empty. You add an 84, and the list just looks like that. Then you add a 72 to the list, and that gets added before the 84. And then you add a 19 to the list, and that gets inserted before the 72. And then you add a 61 to the list, and that gets inserted after the 19, but before the 72. And then And then here we remove the 19, which takes the first one off. And here we remove 84, which takes the last one. Okay, so it's the insert method and the remove method that we're going to write. And all this stuff to do this stuff out here, that's in the main, that's up in here in the main one. And they already give us all that code. So here we ask for the line for inputs, and then we split it out and we add them one by one. Here, this thing adds them one by one, displays out the list each time using this print list method, which they give us. This is the print list method, so it's all there already. And then when we're ready to once that's debugged, then it's when we start debugging the remove part. And then so we take out we remove the comments here, and then that makes this code visible. And so that has to do with when we're testing it, we test it in development mode. And then when we're all done, we just hit the submit and it tests it. The data is, we put the data here. So for this thing, we would do like to test when we're ready to test them both, we put this here. And we put this down here. And then we run the program and it doesn't do anything because we haven't written the method to insert yet. Okay, and it doesn't even do the remove part because it is commented out. See, so that doesn't get executed. All right, so anyway, so that's the task. Oh, so I was going to show you here. So this is what inserting and deleting have. So it goes up. So let's say we're at the place where we are, no, let's go over here again. Okay, let's say we have, let's say we have 84, 72, and 19, and we're going to insert 61, okay? We have, first we're going to insert, well, okay, after we've inserted 84, 19, and 58, we have 19 is here, would be here. 51 would be here, and 84 would be here. And this one is not there. Okay, and so we have the linked list looks like this now, where this goes to here. These are the next pointers here. I gotta get back here and show you this. I should go over the node. Node Java. This is a node. And there's three fields. A double, that's the data, and then there's the next. This is next. It's a node. It's a pointer to a node. Next pointer, and this is previous. And to create an instance of a node, you use this constructor, and so has initial data, and then the next and the previous aren't linked to anything. Here's a constructor for if you actually already have the next node and the previous node pointers, or you already have them, you put them here, and these are addresses of those nodes. This is the get data. Recall it's data, next, and previous. Okay, so this is how you return the value of the data field. This is how you set the data field. This is returning the next pointer, the next field. This is how to set the next field. This is getting the previous. This is setting the previous, and that's it. So that's the node class which we're using. So that's what we're talking about here. And so here we've got this 19 next is pointing to 51. 51 next goes to 84. The previous is this. The previous is this. This previous is null. This next is null. And we have a head equals, the address. When we're referring to the head node, we're referring to this node here, which is the beginning node. And what we want to do is we want to insert 61. Is that right? And so we're going to insert 61. And so it's going to look like this, where we have a 61 here. I'm going to create a 61 node. And we need to insert the node right here. This is where we need to insert 61. So what we need to do is we need to, I'm going to move this. I'm going to move this. And I'm going to put it right here. This is where we're going to add it. And what we want to do is I want to change color now. We're going to make this link, we're going to break this link and have this go to here. And we're going to make this link go where this link went. This link over here went over to here, and we want this link now to go where this link went. We want this link to go where this link used to go. But after we add 61, it's going to be like that. And so that takes care of the in and the out of the back link of the previous links. And then for the next links, instead of this is going to go to here. And instead of this is going to go where this used to go. So we take, the order would be, first we would take this link and put it here. And then we can take, we take this link and we make this equal that. And then we make this link then we create this. What did I just do? All right. So anyway, that's how we add. So we're basically changing. We're having to write. We have to write a new. We have to update this next. We have to update this previous. That's how it affects the existing list. And what we end up doing is putting values in for all four. We're putting values in for the previous year and the previous and the next year. So anyway, so that's adding. Now, let's say we want to remove. So this is adding. Let's see. This is adding or inserting 61. Let's use the terminology here that they're using for this particular insert 61. Now let's do learning how to use this thing. I don't need to do that. Anyway, I'll erase this. Whatever. Okay, so let's so now let's remove 51. Okay, so I'm gonna remove 51. So we have 1951 and whatever 61. It doesn't matter. Now we have 61, 51. Is that what it was? Okay, anyway, 19. And this goes to here, this goes to here, this goes to here, and this goes to here. So we want to remove 51. Well, to remove 51, we need to make this. We need to copy this and put that over here. So now this thing goes to here. And then we need to so that changes this forward link, and then we have to fix this backward link. We need to take this and store it here, So the link goes back to this one. This just as this did here. So instead of this thing going back to this one, we make this one go back to this one. And instead of this link going to the 51, we make, probably can't see what I'm doing. Instead of making the next link for 19 go to 51, instead we're making it go to where the next link of 51 went. Anyway, so that's how we remove 51. Okay, so those are the things we have to do. And we just have to get the order that we write these things. We have to reference them correctly. And we have to get the order that we write them, that we update them in the right order. Otherwise, because we don't want to overwrite something and then we don't have that information to copy into something else and so on. You know what I'm getting at. Okay, so, and we're going to do this in Visual Studio. So let's go, let me pull up just go right click, open a terminal. There's a terminal. I have two of them open now. And just type code, and my Visual Studio Code opens up. And I'm going to click the, if it opens up and there's stuff open, then you just may have to close everything. Close those down to this point where there's nothing open. And you click on the icon there, and you should see Create Java Project here. Click on that. And Build Node Tools is fine. So I'm just going to click on that with Node Tools. And it asks me where I want to put it. And I'm going to put it on my desktop inside my ICS211 folder, inside my summer 2024 folder. And I'm going to name it. So this is the folder. So click on select the project location. And now I type in the name of the project up here, and I'm going to call it sorted number list. Sorted number list. That's a nice project. Okay, here we are. And then I'm gonna copy over these from over here. Okay, so I'm not gonna bother downloading. I'm just gonna copy them from here and make sure I got the default templates. And so I'm gonna go file, new file, and I'm gonna name the first one lab program.java, enter. And I'm going to put that inside source, create file. And now I have this here, and I might as well, while I'm at it, I might as well find lab program Java, and I might as well copy this whole thing out. And copy, and go over here and paste. Paste. Okay, there's my lab program thing. And then these are because I don't have that class in there yet. Then I'm going to file, new file, and I'm going to call the next one node.java, enter. And I'm going to put it in the same folder that was lab program Java, create file. And over here, now I'm going to go node Java, and I'm going to copy this whole thing. Copy. And this is node Java. And the last one is called sorted number list.java. So let me do new file, sorted number list.java. And I'm going to say create file. And then I'm going to go over here, and I'm going to find sorted number list Java. And this is where we got to type all of our new code. So let me just copy, go over here and paste. Okay, here's my 3 programs. And let me save all. And then so what I can do is if I run this, this is what the one I want to run. I'm going to run it, just see what it looks like. Run debug, run. And it's waiting for me to enter something. So it's waiting for me to enter. So I'm going to enter this, copy, and I'm going to do click here, and then I'm going to right click and say that. I'm going to press enter. And this is what this looks like, which is just exactly what it looks like when we run it over here. Okay. Looks just same. Okay, so so we're ready to go over here. So now let's do our edits over here. Okay, so this is all good. I'm not sure we even use this one. This must be just left over. I'm gonna comment this out. And this is commented out, that's fine. All right, I'll just leave this like this. And no Java, we don't have to do anything. And sorted number list, this is where we have to do everything. There's a place up here to put some private methods, and there is a private, we are going to put a private method, don't need to, but we're going to do that. And then we're going to do the insert, inserts the number, some number that comes in into the list in the correct position such that the list remains sorted and in ascending order, ascending. So it goes from lower to higher. So it traverses up the list until it finds the place to put it. And this removes. Okay, so actually, if we go back to this picture, here we are, what we do is we want to insert 61. How about if I go like this? Okay, so we want to insert 61. Let's just do it. And so we're going to have some sort of pointer, and we're going to call it well, we're going to have some sort of pointer that goes along. It keeps on going next. It starts out at head, and then it goes next. It goes until it finds just the first one that's bigger than 61. First one that's bigger than 61. So as long as it starts at 19, as long as next is not bigger than 61, then it goes to the next one, goes here, and then it looks to see if the next one is bigger than 61, and it is. The next, when it's here, it sees that the next one is bigger than 61. Okay, so now it knows that it's going to insert that it inserts right after this one. It knows that 61 goes right after this one because right now the next one is bigger than 61. So it knows 61 goes in there. And so from there, it can start messing with the links. Now, I don't think that's how I wrote my code. I think I actually wrote my code where it stopped at the one right afterwards, which would be 84, and then it knows that it's going to have to do the update just before it. So I don't know. Let's see how I wrote. Let's see where this gets us now. All right, so I'm going to start by doing insert. And okay, this is starting it up. Start by insert. Okay, so and it's gonna comes in as a double. And then first of all, I'm gonna see if okay, so if the okay, so it's possible the list is empty. Okay, it's possible there's no list yet. So I'm gonna say if head equals null, in other words, the list is empty. If that's the case, then all we do is make head so head's not going to be null anymore. Head's going to point to a node. So head is equal to a new node, and the value is going to be number. That's this thing that it passed in as a parameter. So this creates a new node with a value number, and the head and the tail of this new node is null, which is fine. That's when we want to leave it. But this is also keeping track of a tail pointer also. Oh, yes, the sorted number list. keeps track of a tail. Okay, so we are basically setting head and tail. It's not pointing to anything. When it starts out, it's null. Here we're making head equal to something, and we're also making tail equal to the same thing because there's only one element. So both the head and the tail point to the same thing. Okay, there. So that takes care, and then we're done. We're done when it's this case. Okay, so that's what we do. It's stupid. It's not tabbing good. I'm gonna retab. There must be some command I can do to retab this. So anyway, I'm learning Visual Studio Code just like many of you are. So let me push this whole if statement in, and then let me push the innards of the if statement in, and then let me push this whole method in. I don't know, is that right? Good enough. All right, so that's what happens when head is equal to null. Now, what happens when head is not equal to null? It means there's actually a list there. Okay, so it's done, it's returned. I don't need to have an else case. I'm just gonna do we're gonna yeah, I guess I use I have the variable I use is insert before. So I'm gonna go with that. That's in my notes right here. So I'm gonna create a new instance of a node. I'm gonna create a new node, and this is gonna store the data. But no, this is a pointer to a node. This is not creating a new node. This is just addressing a node. I don't have a new there. I have a new here that actually creates a new node. This is just uh, a variable that addresses a node, and I'm going to call it insert before. That's going to be the variable, and that's going to start out by equaling the head node. And then I'm going to have a loop while insert before is not equal to null. In other words, why it's still equal to something. Well, that's happening. And oops, shift. And insert before dot get data. This is the value of insert where insert before is pointing. If that is still less than number than what the one we're trying to insert, if that's the case, then go ahead and in, iterate insert before so it points to the next one. Insert before equals insert before dot get next. A pointer to the next one in the list. Okay, so this is going to keep on going until either this is off the end of the list or this is equal to or greater than the number that we're inserting. So in the case of inserting 51, in the case of inserting, no, let's do it. In the case of inserting 61 here, uh, uh, there's 51 is before it and 84 is after it. So when it's at 51, then 51 is less than 61. So this passes this thing. And insert before is not null. It's equal to, it's pointing to the 51, node 51. If so, when this is pointing, when it's insert before is pointing to node 51, it's gonna increment insert before to the next one. And before 61 is inserted, that's going to be 84. So when insert before, when insert before That's an F. Let me get this. This is a lowercase I. When insert before, yeah, I should learn that. Is equal to 84, then that's when it stops because it's the first time 84 this is false. This ends up being false, so it's going to skip out of the while loop. This is still true because it's equaling to 84. This is still true, but this is false, so it exits out of the while loop, and insert before is pointing to the node just after where we want to insert this new node. Okay, so now let's so insert before equals that. Now, if insert before could be equal to the head node, it's going to at least be equal to the head node because if we are inserting 10, if we're inserting 10, then insert before is going to stay equaling to the head node, and 10 would be inserted before the head node. Okay, so anyway, that case is if insert before equals the head node. If this is the case, then we're going to do something. And I'm going to do that pretty soon. Otherwise, the other case is if insert before equals null. And that would be if we were going to insert 90. We're going to insert 90 here, then insert before would get incremented to this, whatever that is, and that's null. So insert before would be equal to null, and because 90 should go there. Okay, so that's the other end case. That's this case. Otherwise, this last one is all of the cases where it's inside the list. It's where insert before is going to equal either 51 or 84, but not null. So insert before is inside here. It's not at one of the endpoints. So we've taken care of the first endpoint, which is if it's equal to the head. No, we haven't done that. Okay, so if it's equal to the head, insert before is actually the same as the head pointer. Then we want to set the head of the current head of the previous. That's backwards. Previous. We want to set that equal to this new node, and I guess I'm just going to create the new node right here. And that the value of new node is going to be the number. I'm going to use the constructor now where you pass it all the values. It's going to be the first argument here is number, and then it's going to be the head node, which is where the head is currently pointing. That's the before. No, this is the after. Yes, the after. The next node of the one you're inserting is going to be the current head. So this is the next, and the previous is null because it's going to be at the beginning of the list. Okay. So this sets do I need another? I guess I need another one. Yeah. This sets the new previous head. See what we're doing is we're inserting 10. Remember, we're inserting 10, 10, and 10. And this is still, we have to set, this used to go back to null. Now it's got to go back to 10. So that's set previous for the head. Head's still pointing to that. And then the next thing we're going to have to do is, we have to get, the new head. Yes, okay, the new head. Okay, now we can reset head. Head is, we have to make head, head point to here. And that's what the next line is. So head dot, head equals head dot get previous. And oops. Okay. And the idea is that we take get previous of head is, let me just set that. Oh, okay. All we're doing is okay. Yeah. Okay. So head is now equal to this. Yeah, head. We have set this link, and now we have to set head equal to this link to this thing also, and that's what this is. Head equals head. The previous heads, the previous value of heads, previous link. Anyway, I think if you think about it enough, you'll believe me. All right, so that takes care about when it's before the head. And insert before the head. Before equals. Insert before equals head, we set the head. Okay, if insert before is equal to null, yeah, that's that one. Okay. Tail dot set next is going to be the new node. And the next is null because it's at the very end. And tail is the value of the new tail is the next field. No, is the previous, because it's at the end, the previous of this new node. The current tail is going to be the previous, is going to be this new node, its previous link is going to be the current tail because this new node is going to take over as the new tail. It's the new tail. So that's what this does. And then we need to say tail equals tail get next, which is similar to what we did before for head. And then finally, when it's in the middle, I'm just going to cut this. What that is. What am I doing here? Oh, I'm going to copy this over. Okay, so we're creating a new variable which points to a node, and we're going to get the insert where insert before is, which is somewhere in the middle, just after the node that we're just after the spot that we're going to insert the new node in. So it's like 84. Let's say it's 84, and we're inserting 61. So this is going to point to the previous of 81, and the previous of 84 is 51. Before 61 is inserted, the previous of 84 is 51. And so we want to get to that 51, and we're going to store that 51 as the previous of this new node. See, so previous now equals 51. Here we create the new node, and with the new node, the before link, this is the next link for the new node, and that would be 81, because the insert before is equaling, it points to 81. And then previous is the previous, what 81, the previous to 84, which is 51. And so this is going to point to 51. So that creates the new node. It's got the number in there. It's got the next link. It's got the previous link, and it's this. And then we're going to set the 84. We're going to set the previous link to the new node, which is now 61. And then it's going to set the next field of the previous node. In other words, 51. It's going to set the next field of 51 equal to 61. So that's the else case of there. So that takes care of inserting. I think that might be it. Let me save this, and let's run and see what happens. Oh, it's still waiting for me to insert. I got to put some kind of prompt in there. But anyway, let's go grab something. I'll grab these numbers, whatever. Copy. And I'm going to go back over here, click here, click paste. And I got an error. The syntax error is line 29. In sorted number list. And it was called by 31. So 31 is where we called sorted number list of 31 of lab program main, but we're in sorted number list, so that's 29. What's 29? Okay, here. Oh, there's an empty, there's an extra left front. Okay, there. Syntax error. Okay, very good. Let's try it again. Okay, I'm gonna go right click, left click. That's when I'm pasting, enter, and look, the insertion worked. It inserted 1961, 72, 84. Very good. So insert works. Remove is oh, that's what it changed to. All right. Oh, good. Okay, so now we're going to do remove. And let's create a variable called nodes. We can use this to access call it node equals head. We're going to start out at the head, and we're going to traverse until we find the one to remove. So I'm going to go while node is not equal to null. Well, node is not equal to null, then do this. I just want to go along. If node get data is equal to the number that I want to remove, then I want to remove the node, and I'm going to create a private method to take care of this. But I'm going to create a method called remove node, and just a node. And this private method is going to go in and delink everything. Because one thing about a doubly linked list is that every node has a pointer to the node that points to it, along with the pointer to the next node. So since every node points to the previous node, and the previous node is what points to it, it's easy to find, to update. Like when you're removing the node, it's easy to update the next field of the previous node and update the previous field of the next node. If that makes sense. It's easy to do. That's what's great about a doubly linked list. You got to take care. You got to manage two links, but it's easy when you want to add stuff and remove stuff. You never have to go and start at the beginning of the list and search until you find the one just before it. So anyway, so I'm going to create that method in a moment. And when I'm done, if I've been able to do that, then I can return true. I'm supposed to return true or false if I was successful or not. And otherwise, if we don't get it and we haven't returned, then we just go on to the next one. Node equals node get next. Okay. And let me fix this. And I'm going to go tab this in once. And then I'm going to tab this in, and then I'm going to tab the innards of the while loop in. Oop, get this one too. And this one is here. Okay, there we go. And I have the innards of the if state. All right. There's probably some anyway. I thought anyway. Okay, so this is the remove, and now all I got to do is write this method, which will actually just pop it out. It doesn't do anything with it. It just removes it, and then it just lets it be wasting memory. There's going to be a garbage collection thing going on sometime, but that's beyond the scope of this course. So it removes it, the node, just that's it. Okay, so I need to write this method. So I'm going to say a private method up here. Private not going to return anything, remove node. And it's gonna take in as a parameter a node. I'm going to call it current node. Current, and this is a method. And so I'm gonna have a couple variables. I'm gonna have say, so we have this node here, this current node. And so I want to grab the get next link and the previous link. So I'm going to say, I'm going to new variable called node, and it's a successor. And that is equal to the current node dot get next. And I also have a predecessor. Predecessor. That's close enough. Equals current node dot get previous. Okay, so now I got what the two links are. The two properties of the node that we're gonna pop out, and the reason is because we have to set the get next of the predecessor to the successor, and the predecessor and the get previous of the successor to the predecessor. Got that? So if the successor is not equal to null, then we got something there. If that's the case, then we're gonna set the successor's previous property equal to the predecessor. Oh, look, it's already, oh, it knew what I wanted. That's great. Set the successor's previous field to the predecessor. Okay. Now, that's fine. If the predecessor is not equal to null, then set the predecessor's successor set next equal to the successor. Next, set equal to the successor of this node we're deleting. Okay. Now it's possible that the current node is equal to the head. If the current node is equal to the head, then we need to set the head because we're getting rid of the current node, right? So now the current node, now the head is not the current node, it's the node after the current node, the successor to the current node, which is simply that. It's also possible that the current node is equal to the tail. And if that's the case, we want to set the tail equal to this get to the predecessor. We want to set the tail equal to the predecessor. Predecessor. All right. And I think that might be it. All right. So I'm going to save this. Save all. And now I'm going to go back to lab program and I'm going to remove the comments. So the remove thing works. So here, this one, it reads in some stuff from some nodes to remove, splits them up into terms. Then it it changes it, takes a term, changes it into a double number because that's what we're looking at, double numbers for, and then we're going to remove it, remove the double number. Okay, so let's try to run it. Run and debug. Okay, first I'm gonna I gotta enter in some numerals. How about this? I'll enter this in. Copy. I'll go down here. Paste. Enter. Okay, there it's added. Now I can enter these. Copy. That's what's removed. And okay. Okay, so in 43, which is this one, remove, there's a problem in remove, and that's this one here. And inside remove on line 63, it's where we call remove node. And in remove node, the problem is on line 17. So let's go to remove node, which is in here. And it's line 17. 17, that would be right here. Predecessor equal. Oh, what is this square bracket? All right, so this got to be a curly, but let me just take this, cut it, cut. I'm going to get rid of this, and I'm going to go here, and I'm going to right here and paste. Okay, there we go. That's what it's supposed to be. All right. We're in. Okay, so let's try it again. And I'm just going to paste both of these together. Should be able to copy. Go back over here, click down here, right. I want to paste both these lines. Yes. Okay, so it added 84, then 72, then 19, then 61. And now now the next time I haven't hit the enter key yet. 19 and 84. It Here's it entered in the 1984. Here's what it looks like after it deleted the 19. And here's what it looked like after it deleted the 84. Very good. So that works. Okay, so this is now what you'd submit. So you make those updates here and you submit that, and that's where you get that. But in my assignment, I am asking you to add a little menu here. Okay. So let's see how we might do that. It's all going to be in this one. And it's all going to be in here. And first of all, let's add a menu. Let's go ahead and add a menu. Let's see, right up at the top. I'll leave that there. Okay, so public static void print no print no print menu. Okay, and let me spell this public correctly. Okay, and so in print menu, I'm just going to say system out print line, and I'm going to use I for insert nodes, because that's the language of this assignment. Insert nodes in node or nodes. So I'm just gonna when you hit I, it's gonna do the function where we ask for one or more a list of numbers to insert, and that's going to be for inserting nodes. Let's do this just here, and then I'm going to have one for for removing nodes, and I might as well put an output, and I might as well put a quit and a new line. Okay, so let's just take this out here. This is a new line here. This is going to be a remove. Let's use the language of this. R for remove nodes. And this is going to be O for output, just like in the other ones we had. O for output nodes, output list. And Q for quit. Okay, so this is the print menu. So down here, we're gonna say, okay, this is read line input of numbers. We're not even gonna do this yet. We're just gonna print the menu out first. So let me just print the menu out. Print menu. And just like in the other ones, we have some sort of menu option. Menu option equals scanner next. It's just a read in a string, but we're only interested in a character, so we can use equality tests and not have to use methods and stuff. So character at the first character that they type in. Okay. So that's going to be what the menu option is. And then while the menu option, well, the menu option is not equal to Q. Let me do that equal thing. While it's not equal to Q, then okay, so we have a loop here. Okay, so system out, print line, choose an option. Choose an option. And we're gonna menu option is gonna be I'm gonna put this copy down here. And I'm gonna just initialize menu option here as a blank. You get into the loop, and I need to fix this menu option. So let me go here. Yeah, quick fix. That's fine. All right. So and I'm gonna comment everything out down here. Not just past this. I'm gonna do dent, and I'm going to comment all of this out. I'm going to copy this, cut this out, and put it here. Okay. So I commented all this out. Now I'm going to grab this stuff here and put it up in my execute menu function. So it's not all for naught. Okay, so then I'm going to I have a list, sorted number list. Guess I got to declare that up here. Sorted, I gotta declare the list here. Sorted number list, I'm gonna just call it list, is equal to a new sorted number list. Okay. And I need to print menus taken care of. So here I'm going to say list equals execute menu. So it'll return the list, execute menu, and send in the menu option, and send in the list, and send in the scanner thing so we don't mess up. That's good programming practice to use the same scanner. And then when I'm done with that, I can just print the menu again, and it'll display out what the menu options are, and it'll come back and ask the user to choose an option. And when that user types in a Q, it'll come back, oh, it would skip, it would go in here and not do anything and come back. Oh, just right. Hmm. Oh. Okay, well, anyway, if it's wrong, you can fix it. It's not working. Okay, so now I have to just implement this execute menu function, and we're gonna just grab code from down here to do that. So I'm gonna do that right here. Uh, hmm. Yeah, here we are. Okay, so public static, and this is execute menu. It's going to return a sorted number list. It's going to return a sorted number list, and the name of the method is execute menu. And it's going to take in as parameters a character, which I'm going to call it option. And it's going to take in a sorted number list. And I'm going to just call that list. And it's going to take in a scanner object, so scanner, well, that's CNR, because I'm going to be asking it questions. And so that's like this. And let's see, we're going to have a switch on option. We're going to have case of I for insert. Break. We're going to have a case of R for remove. Break. And we're going to have a case of O for output. Break. And that's the end of the switch. So those are the three functions that we're going to have. So insert. Insert looks like this. It's this code here. We're going to read the number, read the input of numbers, do this. Basically, we might not have to do all this. So let me just copy this. I'm going to go up here and insert. I'm going to put this here, and I'm going to paste it. And see what we got here. We're going to input line. Then we're going to split them into terms, and then we're going to we already have a list, so I don't need this. We already have the list, don't we? So then we're going to loop through all the term. We split it using space. So we have these terms here, and okay, so for each term, it's a number, right? It's a list of numbers. We're going to take the term, we're going to parse it into a number, an actual number, and then we're going to display. Oh, this is, to me, this order bothers me, so I'm just gonna, doesn't matter, but I'm gonna put the order right. So then we insert the number, and then we can print out the list. Okay, that's how it was before, so we'll just leave that in there. Okay, and we know the insert works, so that's it. Now we got to fix some things. Input line is I'll roll my mouse over here, quick fix, create local variable. Yeah, that's good. Great setup there. And then I think, oh, that declares terms. Okay. Yeah, okay, very good. All right, so that's input. For output, we'll just do print list. That works for output. So I'm just going to copy this and put that here. I think this works fine for output. And now all we got to do is have remove. Well, okay, let's test this first. Okay. Save, run and debug. Okay. Must return a result. I'm not returning a result. Okay, so let's return the list. Let's do that. Oh, let's do after the end of the switch. Let's return the list, even though sometimes. Okay, return list. We're supposed to return a list. Okay, how's that? Put lines right there. Run it debug. Okay. Insert here. I'm done. Choose an option. Insert nodes. I got an error. Empty string. Okay. Problem is, I think that has to do with, here's what I think the problem is. Let's let's done. So we're calling input line. No. Okay, here we're calling input line. And so this next line reads everything up to a return. Reads everything up to a return key. Well, what was just before this? Just before this, it asked for a menu option. Here, it asked for a menu option. So the person types in I, enter. Well, this thing only grabs the I, it doesn't grab the enter. So there's an I in there, and it calls this list, calls execute menu. It's an I, comes over here, and the first thing it does is it reads next line. Well, that return character that came after the I, because when the user enters I, they press the return character. Well, that return character is still there. So there's a line that's still there. So it reads this next line, and all it does is it reads a return character. So it looks like a blank line to me. So this is a blank line, comes here. This doesn't work. This doesn't work. Nothing works. And it says exception, blah, blah, blah. It's somewhere empty string. So the answer, of course, as we know from previous labs, we just need to absorb the enter. So I'm just going to try to do it here, see if that works. Let me go scanner dot next line. Okay, that should absorb it. Now I hope that doesn't mess these other things up, but let's try this now. Run and debug. Okay, choose an option. I'm going to type I, and then oh, I guess it's waiting for me to enter. It doesn't. I don't have it say. Oh, look, I just go right here. I should be asking it for something, but let me go ahead and test this out. I'm going to copy, paste it here. Okay. It looks like it worked. See? I entered that in, and then it says after 84, after 72, after 19, after 61, and it comes back again. And I choose the option. Let me try the O for output. O. There it is. It printed out 1961, 72. It printed out the list. Then asked me again. Okay, great. Oh, that worked too. So great. Now I need to do something like um, um, system out print line enter one or more numbers on one line, whatever. Okay, so now it'll print out. Now it'll properly ask. Okay. All right, how about remove it? Let's do insert nodes or something. Copy. Insert nodes. How's that? Okay, let's do the same thing for remove nodes, system out, out, print line, remove nodes, system out, print line, enter one or more numbers to remove from the list, whatever. Okay. And I'm going to leave this to you, but all you got to do is take this, and paste it up here, and it should work. All right. And so that'll complete the last lab of the semester. So that completes this video, and completes so I've made videos for all the labs in the course, in the assignments, the fourth credit for the assignment. And it's a couple weeks left in the semester, so you still got plenty of time. You should really get all the points. Follow the directions carefully so it's easy for us to grade. And then I'll make more videos, but it'll be more related to the course. Got 2 weeks left. Hope this helps. Thanks for watching.